Alright, so today we're going to talk about how to classify different types of triangles by their angles and their sides. So first we have our angle designations. So an acute triangle is a triangle where all three angles are going to be acute angles. And acute is defined as, again, less than 90 degrees. Equiangular triangles are a special type of acute triangles. These are ones where all three angles are equal. So all the angles are equal to 60 degrees, so yes, they're acute, but it's technically an equiangular triangle because they're all the same measurement. The right triangle has only one right angle in it, and an obtuse triangle has only one obtuse angle in it. We'll discuss the reasons why there can only be one right angle or one obtuse angle in a triangle when we talk about the sum of a triangle and we add up all of the angles. So those are angle designations. By the sides, we have three choices. It's a scalene triangle. If none of the sides are the same measurement, they're all different. The triangle is isosceles. If two sides are equal to each other, the third side would obviously be different. And if all three sides are congruent, then it's equilateral. So we have this figure right here. We want to classify what each one of these triangles are inside this overall shape. So triangle ABD would be this triangle. So it starts with A, B, and D. So as we can see immediately, all the angles are different. We have 60, 40, and this whole angle is 80 degrees. So they're all different, so it cannot be equiangular. And none of the angles are equal to 90 or bigger than 90. Since they're all less than 90, this is an acute triangle. DEB would be here, DEB, this triangle right here. As we can see, one of our angles is an obtuse angle, so this would be an obtuse triangle. Triangle AEB, well, all angles are the same measurement, they're all 60 degrees, so this would be an equiangular triangle. And then finally, triangle BCD, this triangle right here. As you can see, we have one right angle, so that makes us a right triangle. Alright, so those are its angles. If one does it by its sides, same concept. We'll take a look at these triangles. So triangle KFG is this triangle right here. So now this side is 10, this side is 5. We don't know the side KG, however, it's not equal to FG. If it had been, there'd be a tick mark here as well. Since all three sides are different, this is a scalene triangle. Triangle HJK is right here, HJK. Well, if we take a look at this, one side is 10, another side is 12, and on this side, we'd have to add these two pieces together. 8 and 4 is 12, so that makes it an isosceles triangle. Triangle FKH, this triangle right here. So we have one side is 10, another side is 10, and then the third side, the two pieces have to add to 10 since they're all the same measurement. This is equilateral. And then finally, last one, KIH. So KIH is right here. Again, one side is 10, one is 4, and this side is unknown, but it's not equal to 10 or 4 because we would have a double tick mark somewhere in one of those two spots. So they're all different, so this is scalene. And that's all you have to do really to classify your triangles is by the angles and sides. If they asked you to do both, they would fill in angles and sides together. It's the same process. You take a look at the angles, classify it that way, look at the sides, classify it that way. Alright, so I'll see you next time we talk about the angles inside triangles and what they have to add up to.